The tool breaks, the handle splits at the socket. The blade snaps at the base. You reach for a replacement, and there is no replacement. Not in this workshop, not in this town, not in this region. The parts catalogue lists the component. The warehouse has not received stock in 11 months. The next delivery has no confirmed date. In a modern workshop, this is a significant inconvenience. You place an order. You wait. You do not work until the part arrives. Behind the Iron Curtain, this was not an option. The work did not stop because the tool broke. The farm did not wait for a replacement axle. The workshop did not pause production for a replacement drill bit. The carpenter did not suspend the roof repair for a replacement chisel. The tool was fixed, or a new tool was made, from whatever metal was available, using whatever heat source could be generated, shaped by hand with salvaged equipment and the kind of metallurgical intuition that develops in people who work metal every day of their lives, without the option of buying a better version. Soviet factory workers forged replacement cutting tools from car spring steel, because car spring steel was what was in the scrap pile, and because they had learned, through the transmission of practical knowledge across generations of metalworkers, that spring steel is an excellent blade material. Rural blacksmiths hammered replacement agricultural implements from salvaged rebar, from broken machine parts, from anything ferrous that could be heated to working temperature and shaped under a hammer. Village craftsmen ground cutting edges from concrete nails, from broken saw blades, from the worn teeth of salvaged gear wheels, because hard steel is hard steel, regardless of what it was before it became a cutting edge. They did not have metallurgy degrees. They had fire, hammer, and the accumulated knowledge of people who had been solving this problem for longer than modern industry has existed. Stay with me, because number 4 on this list is the most useful zero-cost tool-making technique ever developed in the Soviet industrial tradition, a method that produces a blade of genuine functional quality from a piece of steel that is sitting in every scrap pile in the world right now. Costs nothing, and requires no specialized equipment beyond a fire and a hammer. Let's begin. Number 1. Car spring steel blade making. A car leaf spring is one of the most useful pieces of steel in any scrapyard. This is not an opinion. It is metallurgy. Leaf spring steel is a medium to high carbon steel alloy, typically in the range of 0.55 to 0.65%. Carbon specifically formulated to withstand repeated stress cycling without fatigue, failure. It is tough, capable of holding a hardened edge, and available in every vehicle scrapyard in the world, in essentially unlimited quantity, at zero or near zero cost. Behind the Iron Curtain, where kitchen knives wore out and could not be replaced, where agricultural cutting tools broke and the parts allocation system provided no replacement, where workshop tools were used beyond their designed service life because no new tools were coming. The car spring was understood as a raw material of considerable value. A Soviet factory worker named Gennady, in a Ural machine shop in 1961, had a problem. The workshop's set of cold chisels had worn beyond usable condition. The replacement requisition had been filed. No replacement had arrived. The work required chisels. Gennady went to the yard behind the workshop where broken vehicle components accumulated waiting for collection. He selected a section of leaf spring, approximately 30 centimeters long. He built a charcoal fire in a steel container. He heated the spring section to bright orange, the color that indicates the steel has reached working temperature. He hammered it into the rough profile of a chisel on a piece of heavy steel plate that served as an improvised anvil. He reheated, he refined the profile, he ground the cutting edge on a salvaged abrasive wheel. He hardened the blade by reheating to bright cherry red and quenching in oil the used motor oil that accumulated in every Soviet workshop as an unavoidable byproduct of engine maintenance. The chisel worked. Gennady made 6 more over the following week. The work continued. The metallurgical principle is not complex. Carbon content determines hardness potential. Spring steel has sufficient carbon to harden through heat treatment. The heat treatment cycle, heat to critical temperature, quench in oil, converts the carbon-rich steel structure to martensite, the hard crystalline form that holds a cutting edge. The skill required is practical rather than academic. Learn to read steel color. Understand the relationship between heat and working behavior. Develop the hammer control to shape hot metal accurately. These are learnable skills. Every traditional blacksmith in human history learned them. Modern tool steel in commercial cutting tools costs money and requires supply chains. Cast spring steel costs nothing and is everywhere. Number 2. The concrete nail drill bit. This sounds impossible. It is not impossible. Concrete nails, the hardened steel nails designed to be driven into masonry, are manufactured from high-carbon steel that has been hardened through heat treatment to a degree that allows them to penetrate concrete and brick without deforming. That hardness, which is the property that makes them useful as nails, is also the property that makes the steel suitable for grinding into cutting tools. Behind the Iron Curtain, where drill bits wore out and replacements were allocated by the state in quantities that rarely matched actual workshop need, skilled workers discovered that a concrete nail, carefully ground on an abrasive wheel, could be shaped into a functional twist drill substitute that would cut through wood, soft metal, and even soft masonry at reduced speed. The grinding technique, the nail, is held at the appropriate angle against an abrasive wheel, and the cutting faces are ground to the geometry of a standard twist drill point to cutting faces meeting at the center point, each angled to provide a positive cutting rake. The nail's round shaft approximates the shaft of a standard drill bit sufficiently for use in a hand brace or a slow-speed drill. The result is not a precision tool. The geometry will not be perfect. The cutting speed will be lower than a properly manufactured drill bit. The service life will be shorter, but it cuts. It makes holes in the material that needs holes made in it. In a workshop, where the alternative is no drill bit at all, a concrete nail ground into a cutting tool is the difference between completing the work and not completing the work. Soviet repair shop workers passed this technique between workshops through the informal knowledge networks that transmitted practical skills across the entire Soviet industrial system, not through official training materials, but through the person-to-person transmission that has always been the primary vehicle for practical craft knowledge. Number 3. The improvised forge and foundry. At some point in the tool-making chain, the question arises, where do you get the heat? Shaping hot metal requires temperatures that a kitchen stove cannot reach. Steel reaches working temperature at approximately 800 to 1100 degrees Celsius, depending on the type of operation required. Forge welding, the joining of two pieces of steel by heating them to near melting and hammering them together, requires temperatures approaching 1300 degrees. A charcoal forge reaches these temperatures. Charcoal burns hotter than wood and produces a more controllable heat source in a compact fire. Forced air, a bellows, a fan, a tube through which air can be blown by mouth, increases the combustion rate and raises the temperature further. Iron Curtain rural blacksmiths built forges from materials that cost nothing, a clay-lined pit in the ground, a steel pipe buried horizontally at the base of the fire pit to deliver air to the base of the fire, a piece of heavy steel plate as an anvil surface, a hammer. These 4 elements constitute a functional forge capable of working any ferrous metal. Soviet collective farm blacksmiths cast replacement parts for agricultural machinery using the same principle. Sand from the nearest stream, clay from the subsoil, charcoal from wood. The metal charge was whatever scrap was available, broken tools, worn machinery components, any ferrous metal that had reached the end of its original life. Cast parts are more brittle than machined parts. But, for brackets, housings, and non-impact components, field foundry castings performed adequately. The work continued. The machinery kept running. The harvest was not lost to a broken part the official supply system had failed to provide. Stop here, look at the tools you depend on right now. Every cutting tool in your kitchen, every hand tool in your workshop, every piece of equipment you use to maintain your home and your land. Now ask yourself, if every hardware store and tool supplier closed permanently tomorrow, how long before the degradation of your tools stopped you from doing essential work? Most modern people have no answer to this question because they have never needed one. The supply chain has always delivered, but supply chains break. Hardware stores close. Tool suppliers go out of business or simply run out of stock in the specific items that a specific person needs at a specific moment. The Soviet worker who understood spring steel metallurgy and basic forge technique was not dependent on any of this. The tool that broke today was the raw material for the replacement tool that would be working tomorrow. Write in the comments. Have you ever made a tool or repaired one beyond replacing a broken handle? Number 4. The rebar knife and blade system. Construction rebar, the steel reinforcing rod used in concrete construction, is medium carbon steel in most specifications, not as high in carbon as spring steel, but sufficient in the right diameter and with the right heat treatment to produce a functional cutting blade of serviceable quality. Behind the Iron Curtain, rebar was everywhere. Construction projects left offcuts, demolition produced salvage. The material was considered low-value scrap and was available for collection at virtually zero cost. A piece of rebar of appropriate diameter, 10 to 12 mm for a kitchen knife, 16 to 20 mm for a heavier chopping blade, heated to working temperature and drawn out under a hammer to reduce cross-section and increase length, then ground to a cutting profile and heat-treated, produces a blade that will hold an edge through normal kitchen use and serve adequately for field tasks. The Soviet rural tradition of rebar blade making was not a specialized craft practiced by trained smiths. It was a household skill. Farm families who needed a replacement knife, who had worn through their last blade, who could not wait for the next market to appear, they made one. The technique was transmitted through the same informal networks that transmitted all practical craft knowledge in a society where formal technical education was organized around industrial production, rather than individual survival skills. A grandmother in a Ukrainian village in 1965 who taught her granddaughter to grind a kitchen knife from a piece of scrap rebar was transmitting knowledge that had no place in the Soviet educational curriculum. It had no category in the official knowledge system. It was simply useful, and so it survived, person to person, generation to generation, in the spaces between the official system and actual life. Number 5. The file and abrasive reclamation system. Files wear out, grinding wheels wear down. Abrasive stones lose their cutting action. In a modern workshop, worn abrasive tools are discarded and replaced. In a workshop operating without reliable supply chains, a worn file is not garbage. It is a problem to be solved. Behind the Iron Curtain, file reclamation was practiced in two directions simultaneously. Restoration. A worn file can be partially restored by acid etching. Immersion in dilute acid vinegar is sufficient for light treatment. Stronger acids for more aggressive restoration removes the metal swarf that has compacted into the file teeth and partially restores cutting action. not to original performance, to a level of performance that extends the useful life of the file beyond what its physical condition would suggest. Repurposing. A file worn beyond restoration still contains high-carbon hard steel in its body, annealed by heating to bright red and cooling slowly, then ground, shaped, and rehardened into any cutting tool that requires a hard steel body. Gravers, scrapers, small chisels, scribe points. Soviet watchmakers and instrument makers in chronically undersupplied workshops developed this repurposing as a standard part of their craft practice. The worn file was not the end of the tool's life. It was the beginning of several smaller tools' lives. Here is what all of this means. The modern industrial system has produced a relationship between people and tools that would have been incomprehensible to every craftsman before the 20th century. Tools are purchased. When they break, they are discarded and replaced. This relationship is efficient when supply chains function. It is catastrophic when they do not. The Soviet industrial worker who could forge a replacement chisel from a car spring, grind a drill bit from a concrete nail, cast a bracket in a clay pit, and restore a worn file through acid treatment was not living in the past. He was living in a present that did not depend on a supply chain that could fail. Every tool he needed, he could make. Every tool that broke, he could rebuild. The supply chain could not stop him because he had made himself independent of it. In a functioning modern system, sophisticated purchased tools win. In the conditions that any serious supply chain disruption would produce today, the ability to make tools from scrap metal is not a quaint historical skill. It is the difference between working and waiting. Learn to read steel color, build a small charcoal forge, understand the heat treatment cycle. The scrap pile behind every workshop is full of the raw material for every tool you will ever need. The Soviet workers knew what to do with it. Now you do too.